Hello. A couple of days ago, I received this thermal camera from Optris, which is a company which specializes in thermal thermometers and infrared cameras. So here you can see their website. They've got many different thermometers and thermal cameras. This one is, for example, the XI400. They also have some small books explaining the principles of non-contact measurement. For example, there is this one. So this is a guide to how thermal cameras work, with the history of the rays were discovered, the properties, how they are measured. Now this camera is very useful for measuring things. It can measure from up to 900 degrees centigrade. I definitely have many ideas on how I could use it. For example, I can measure the temperature of my circuits. If I make some rocket engines, I can also measure the temperature of them. To see what the thermal image, we can go to PIX Connect, which is the software, the loading. When I plug in the camera and it finishes loading, we should be able to see. Okay, so here's the image. At the start, it looks very blurry, but after I adjust it slightly, it starts working. Okay, so here you can see my hand on the mouse, for example. And if I move the camera, we can see the computer. You have to adjust the focus manually, as you can see here to see well. If I move my mouse over a certain point, you can see the temperature. So for example, my hand is at about 34.20 degrees. Another interesting thing about the infrared rays is that many things which you see as opaque, quite reflective in the infrared range. For example, if I point it at my monitor, you can see me, which is quite interesting because usually we see the monitor as black. And also there are some interesting demonstrations which can be done. For example, here is the desk. It kind of looks like a mirror, but we can still measure the temperature. So if I drag my finger across it, we can see the heat force generated by friction. Another interesting thing for me is that if you have something like this bubble wrap, which I wouldn't say is particularly transparent, in the infrared it's quite transparent, so you can sort of see my hand on the mouse or the computer. Instead, materials like glass, which you usually think of as transparent, are reflective in the infrared. Something which I find quite interesting is that since the amount of infrared radiation emitted by an object is proportional to its emissivity, the more reflective an object is, then the lower the emissivity. So if we have a piece of metal, for example, here I have this small bit of metal, we can see that we can't really measure its temperature based on which direction it's facing. It will tell me the temperature of the reflection. For example, if I turn it the right way, you should be able to see me. That's why it's hotter. If I turn it the other way, it seems colder. In fact, if I have like a heat sink, even if it's at like 200 degrees centigrade, I can only see the reflection. To fix this, we can put there are some special white stickers which can be put of a said emissivity. That's very useful for measurement. Or something which I have noticed works is if I have a piece of iron, if I just heat it up to like 900 degrees or 1000 degrees centigrade, then it will develop a thick oxide coating and I can measure the temperature of that. So this is a brief overview on this camera. For now, that's all. In the next videos, I could, for example, use this camera to measure the temperature and heating of my GPS sensor. That's all for now. Bye.